All right. If you're here to hear about JShell, the new interactive way to access the Java language, you're in the right place. I'm Robert Field. I'm the architect of JShell and the lead engineer. I'm a member of the Java Core Language and Tools group at Oracle. Oracle has to tell you that anything I say could be fiction because we haven't shipped it yet. So what am I going to talk about? I'm going to talk about what JShell is, why you would want to use it, including who would want to use it, and go through how you would use JShell, and then actually see it in action, and then talk a little bit, just kind of 10,000-foot view of what the architecture of the JShell implementation and the API are. And then we'll talk about questions, and I'm open to questions as long as there's enough time as we go along. So starting with what is JShell? Actually, I want to know a little bit about you, if I can see you at all. Who's heard of JShell before Devoxx? Okay. And who's actually used JShell? Okay, I think that's one. And for whom is this entirely new thing here? Okay, pretty much everybody. Okay, JShell is a tool. Well, it's a tool and an API, but what I'm going to be showing primarily here is the tool for dynamically interacting with the Java language. It's what you may have heard of REPLs or read, evaluate, print loops. Usually in dynamic languages, this is a REPL for the Java language. So the basic idea is you type in a snippet of Java code and you immediately see the results. The implementation of JShell is deeply integrated in the JDK 9 platform. And it's part of the JDK 9 platform, and it builds on top of the JDK 9 platform, and we'll talk a little bit about the implications for that. So what I'm going to be showing is a tool. It's a lot easier to show a tool than to show an API. But everything the tool can do, the API can do, which means if you don't like how the tool works, you can have that functionality quite easily in your own tool, or if you want it built within your own tool. It's also important to talk about what JShell is not. It's not a new language. The whole point of it is to have interactive access to pure Java code. Every snippet of Java code accepted by JShell corresponds to a production in the Java language specification. So it's very literally pure Java, but just pieces of it. And people say, I've said frequently, well, can we add this and this because we've always wanted that in Java? It's not going to be in this either because this is not a new language. It's an interactive access to the present language. And note, this is not some replacement for the compiler. The idea is this is a way to explore. The compiler is still how you compile programs. And anytime you have a tool that works with source code, there's a temptation to, well, if you add this, and pretty soon you have an IDE. We really don't want to slip down that slippery slope. There's an API for adding this functionality to IDEs, and we're working on that, and we encourage more addition to other existing language tools. Okay, so why would we want JShell? There's really kind of three audiences for JShell. One is programmers that are new to Java. This is a great way to learn Java, or in fact, if this is Java is your first programming language. So you can start with typing in an expression and seeing what that does. That's a much easier starting point than declaring a class, declaring a main method with, defined string arrays and has access permissions and so forth, and not knowing what any of that means. You can start at a reasonable point and build up from that. And all of us are newbies again and again as new APIs come out, or we want to use APIs we haven't used before, or new language features are added to Java. So it's a way to learn those very effectively. Ongoingly, though, it's a way for prototyping, for building up complex code at any granularity you're interested in. Type in the thing you're thinking about, see the response, and build up from there. Okay, so if you want to explore now without JShell, you're basically stuck using the edit, compile, execute cycle. And you need to build a full program. You need to write some class declaration, put any imports you need, and you need to declare a main method and put in prints or whatever, however you want to see your results. So, and you need to cycle through this. You edit the code, you create it, then you go through a compiler and IDE to compile it, and then you execute it. So here's our example without JShell. So everything in bold black text is what you would type. You'd enter an editor, you'd type in your class declaration, your main method declaration, you put print lines with system out, and then you would need to compile it. And then, if you're lucky, it will compile. You won't know till you get to that point. Then you execute it. Okay, and you see the result. Okay, and this example, by the way, is for example, you want to know the difference between right shift and unsigned shift. So the results we get back are negative numbers. So the results we get back are first -1. That tells us what happens with the regular shift. But the response we get for the unsigned shift is obscured by the fact that I printed it in decimal. So I can't really see what's going on. We then need to go back through the cycle, change that to print in octal or hex or however we want to see that. Okay, what about with JShell? You just type in the snippet of code you're interested in and immediately see the results. That's all there is to it. So in this case, we type in the first expression we're interested in, -8 shift 2. We see the response, which says that it's -2. You'll notice also that it says it's created a temporary variable called $1. That's so if the value you're interested in, you want to use that further, you can reference it with $1. Now we type in the second one, and with the unsigned shift. And at that point, and we see the result. At that point, we've done everything we wanted to do in terms of exploration that was on this slide without JShell. And here, okay, well, now we want to do it in octal. We're going to use a printf, print it in octal form. Now, notice I didn't say system out println, and printf. I just said printf. Well, that's actually a method we've added, and I've said we're doing pure Java, so we'll talk about more about how that gets to be in there, and we're still pure Java. So how do we use JShell? Once you have a JDK 9 installed, you just type JShell, and you're there. There's two kinds of input you can give to JShell. One is these snippets of Java code I've been talking about. The other is commands to get information and to control how JShell works. Notice that both of these, by the way, can be tab completed. We want to keep down the amount of typing you need to do. So, for example, you want to create a variable, foo. You just type in string foo equals, in this case, howdy. And in this case, it will tell you it's created that variable, what the type is, and what the value is. What about a method? So we want to create a Fibonacci method. We type long Fibonacci, open brace, hit return. Notice this time it gives us a different prompt. It knows that that input isn't a complete snippet of code. And we can enter our whole method. At the end, it says we've added a method. You can also add classes, interface, enums, annotation interfaces. In this case, we just have a simple interface to convert a floating point number into an int. And what about just expressions? You just type the expression. We can use the method we just created and call that Fibonacci method with 10. We immediately see the expression value. Again, there's temporary variable for that. Statements. You can put in any statement as well. In this case, we're using the temporary variable from previous slide, and printf, and there's our statement. And it immediately runs, and you see the value. What about imports? Well, actually, JShell comes with a set of imports predefined, but what if you're using something as your talk did before using swing? Well, you just type in the import for swing, and it doesn't have to be in order. It can be at any point. That's true of all of the snippets you enter. You can add the import as you go along. In fact, the only kind of snippet of Java code you can't add is a package declaration. That's because everything in JShell is in one predefined package. Okay, let's just do a few examples here. So we could define a lambda expression using that interface we just declared. Define the conversion from float to int using math round, and we've added that lambda. We can use the lambda immediately, test it out, see if we got what we want, and we say lambda convert 2.5, and so the other thing you get immediately is errors. In this case, you can see that it won't let you just turn 2.5, which is a double, into a float, and you get an error and shows where the error is. And you can add the cast you need to do to make that work. You don't have to retype this from scratch. JShell has a history mechanism. You can just basically go up arrow and edit what you have, and there are your results. What about commands? The commands are differentiated from snippets by having a leading slash. They do a bunch of things, like they show the state of your execution. They allow you to configure how JShell works, including how it displays. They set up your environment, let's say what your class path is, and things like that. And what a startup is, what the startup is, and I'll show what that means in a little while. And allows you to look at your history of what commands and snippets you've entered. So commands too have tab completion. They also have shortcuts. So the most useful command to start with is /help, which lists all the commands there are. This lists both the shorthand, single character version, which there's some arguments since you can do tab completion that you don't really need. We could just have /l, hit tab, and it would fill in the list. And some of them have optional arguments, like the list there shows that it's list all. We're not going to go through all these commands, of course, but the help is there when you need it. Okay, a real common command you might want is list. So list all the current active snippets. This is a list of the snippets we've added in the previous slide. And note also that it has a number in front of it. That's the snippet ID. And that ID is something you can use to reference it, to edit it, or if you no longer want that as part of your set of snippets, to drop it. You also see that in backtraces. And a bunch of other queries. You can query for which variables you have. Here we see both the explicitly defined variables like foo and lamb, and the temporary variables that have automatically been created for us. Similarly, there's slash methods to get information about methods, and slash classes to get information about classes, interface, blah, blah, blah. Okay, it's often useful. You're not writing programs with JShell, but you frequently want to go back to where you were and continue. So you can save your work with a slash save. If you exit JShell, you can then re-enter it, open it back up, and it will reread them, re-execute them, and basically you're starting from where you were. Now, the first slash list I used didn't have any parameters. Slash all will show you all your snippets. Remember the first time I used slash list, I said all your current active snippets. That doesn't include your startup snippets. It doesn't include any failed snippets or overwritten snippets. So in this case, list all shows what you start with before you've typed anything. And there's a number of imports that people find generally useful, like Java util and IO and so forth. The net. And the very last thing you see is there's a declaration for printf. It's just because you don't want to have to, even though you can, for simple things, you can just enter them and hit return, and that's the value expression. You'll immediately see the results. Often you want to print things as part of a method. You don't want to have to type out system out printf. So we've pre-declared that. Because that's a valid snippet, we've not changed the syntax of Java, but we'd really like this all to be imports, and we're hoping this guy over there will help us add printf and println and all those interesting things as static imports to Java, so we could use those anywhere in our Java programs. Basically, we want them to be as close to one-to-one as possible. Okay, wait. So first of all, who thinks this set of imports is exactly the right set? You wouldn't want to change any of this. Nobody, okay. How many people would want to customize this? Your set of imports that you would typically use would be different. All right, well, that's good because you can change your startup. Basically with this set startup command, we'll set your startup file that you'll use every time you start up. You can use save start to get the current set to just modify it. Note that you can put commands as well as snippets in a startup file. So for example, in the feedback you're seeing, a lot of people are going to go, well, that's really verbose. And that may change because a lot of people say that's really verbose, but I actually like for a new user starting to see something that is really friendly. Well, by changing your startup, you can add a /feedback command to set your feedback level. So you could set that to be concise. And both the snippets and commands have command line editing thanks to JLine 2. You can go up and down through your command history. You can hit enter to re-execute a previous command. You can use Emacs bindings to edit what you've had before. And you can use tab completion to complete an entry. Also, in the case of you've got to a call to a method, you want to see what the arguments to that are, you can use Shift Tab. Finally, if you're executing something and it's taking too long or is in an infinite loop, you can hit Control-C and come back to the prompt. All right, well, this is where you actually get to see JShell in action. Okay, so I just type JShell, and that's all there is to it. Now, I'll get my cheat sheet back. Okay, let's start simple. We'll define a variable. Okay, we've typed in the variable declaration, and there we go. Notice I didn't have to put a semicolon at the end of an input. Any snippet, it will automatically detect that you're missing a semicolon and put that in for you. If you want to know the value of something like S, I can just type S, hit return, and you see the value. Now let's show tab completion. Well, what can I do with this S? I can do S dot, hit tab, get a whole list of things I can do with string. So for this example, let's say we want to convert it to uppercase. I go to up, and I can hit tab again. It would help if I typed that right. There we go. And there we go. And it's converted it to uppercase. And notice it's put that in a temporary variable. We can look at the temporary variable by just entering the name of it. Okay. The next thing you want to do is how do you work with things? How do you replace previous definitions and look at the history? So let's say we want a method that, given a string, gives us half of it back. We'll use, I just hit tab to get the sub there. Hit again, I'm a really lazy typer. And then I want to look at the length, because that's half, I want half of the length. Again, hitting tab. Divided by 2. And there's our method definition. Well, let's give it a try. That's part of what you can do in JShell is immediately try things out. So let's say half of rabbit. And we get half, but actually I wanted the first half, not the second half. I don't, the way I would get a new definition for half would be to re-enter it. Now I could just retype it from scratch, and it would recognize that it has the same signature, and that would be the new definition. So that's basically how you replace things. Again, I'm lazy. I can just go up. First level shows the previous thing I did. Second up takes me back to my definition. I can just go in here and make it the way I want. And now notice instead of saying it added the method half, it says it modified it. And that it overwrote the method. Then I can do my test again, and there we go, I have rab, first half of rabbit. Okay, build up the complexity a little bit more. Let's say we want to define a method for the volume of a cube. So, not a cube, I mean a sphere. So we need the radius as an input to the method, and return. So it's 3/4 of pi times the cube of the radius. And, well, I said the cube. Let's make it actually cube. All right. Now it says it's declared that definition, but I didn't tell it what pi was, and I didn't tell it what cube was. This is basically a forward reference. Like sometimes your code will need forward references, either because they're circular references, valid circular references, or if you're in a prototyping mode, you may be like this. Well, this is what I want to do. In the middle of the definition, you want to reference things that haven't been referenced yet. It allows that. It's added this volume method. But it says you can't actually invoke it until you declare what pi is, until you declare what cube is. Well, let's say if I ignored that, let's call it anyhow. It just says you've attempted to call it, but you haven't defined what pi and cube are. Well, the way we want to define what pi is math star, okay? Oops. So now we can try out volume again, see if we got it to work now. No, it says you still haven't defined cube. Okay, the cube of x is usually x times x times x. And we can try it again. And there we go, we have a result. Is that the right result? Anybody catch what's wrong? That's just pi, not 4/3 pi. The reason is that was an integer division. So we can just go back up here, edit it. Try it again. And we have the result we want. All right, before I go further, anybody have questions at this point?
Say I define a method, and then I decide it needs a parameter. I can redefine the method, but would still have...
Okay, so the question is, let's say you define a method, and then you decide you want a different parameter on it, or add a parameter. Well, if you have a method with a different signature in Java, it's a different method. It's a method overload, and those are perfectly valid. So you will have just defined an overloaded method.
But is there a way to unbind the previously defined method?
Yeah, so you can basically say, so there's our methods. We define vol and cube and what have you. I can slash so our volume declaration is ID 15, and I can just say drop 15, and that's not one of our methods anymore. So I saw another question. Yes?
Can I add my own class for my own package?
Can you have a, so you can use, so you'll notice one of the, kind of in the middle-ish of the screen there is a /class path command. You can basically specify a class path for your, so you can basically work with your existing code and do calls into your existing code or libraries or whatever you want. You can add anything on your class path you want. Does that answer your question? Yes?
I have two questions. One of them is, if I call the same method twice, and both times the method has same arguments and returns the same value, will the results be stored in different temporary variables, or will it know that it's the same thing and it just returns the same temporary variable?
So the question is, do you get different temporary variables if you call the same thing? And basically, we initially kind of assigned temporary variables in order. We realized we don't want like numbers for temporary variables and numbers for snippets. So the snippets for which a temporary variable makes sense, like an expression, have the temporary variables correspond to the snippet number. So if it's snippet 10, it's going to be temporary variable 10. So you will get a new one every time.
Another question I had, if I made a method and it throws an exception in the middle of the method, what will it report? Will it report the line number like third line in the method, or what happens?
Yes, it will return the line number in the method. And so the question is, if you have an exception, the backtrace, what does it show? It will show the snippet number. Actually, we just changed that functionality, so it's currently broken, but we know about that. We'll fix that quickly. The snippet number and the line number within the snippet. All right, let me move on. Okay, one more.
You have the open file command. Can you also do that before you open JShell? So like from the Unix or Windows command line?
So the question is, can you open from the command line? And yes, you can, as a parameter to the JShell command, you can basically specify snippets, what you're basically a file to open and execute. Okay. So I get requests to, like, how do you use that this stuff in the real world? Well, here's a case where, well, let me back up a second. So as much of the functionality as possible has been built directly on top of the JDK tool structure. And so the source code analysis uses the compiler. And so one import is also handled that way, but I needed some information that the compiler APIs couldn't get me. So I used a pattern. So it's a pretty ugly pattern you can see there. And I developed that using JShell because it's really much easier to play with that rather than cycling through the whole program every time. So let's look at that. So there's our ugly import pattern. We can, import. So let's do a matcher. Helps if I use the right punctuation. Let's test out, let's see if it works for as kind of a standard import. Java-lang star. Does that match? Well, what it gives me back is a matcher. That doesn't even tell me if it matches. But I have this temporary variable, 18 in this case, so I'll use 18, and then I'll query whether that matches. It says, yep, that matches the pattern, good. So that works. And I can also ask, well, part of what I extract in this ugly thing is the full name of what's being imported. So let me do the group query of that for the full name. And it's got back Java-lang star. That's exactly what I wanted. Well, I want to be able to test a bunch of things, so I can write a little test code. This is a great way to test things out by playing with them. So let's make a test method given a string of an import that we want to test to see if it matches. We'll get a matcher called M, which is the import pattern, and then matcher tab to complete it of that imported S, and then we'll do an if that matcher matches yep. If it matches, then want to printf, use that printf function we had before, and basically show if we got the results we want, which is the right full name and the right name, which is what I'm trying to extract out of there. So I go m.group. Anything wrong here is not group. Oop, well, there we go. M group full name and M group of name. So now I'll be able to just check those immediately without having to manually type in those queries. And then otherwise, if it doesn't match, we need to know that immediately. So we'll say no match. Oh yeah, I'll need another. Okay, printf. Else without if. That's.
Curly braces before the else.
Yeah. The if opens with a curly bracket.
Oh, I see. Okay, so we'll go back to our test method, and we want to close this. There we go. So now we have our test method, and we can test a bunch of interesting things. Like, one thing that was reported was that if I put a space after a dot here, that the import matching doesn't work. Sure enough, we get a no match. So we need, this is actually a current bug that was just reported, and so I can see it and fix it and try it out here. I can type in test for other things. Well, is it broken also if the space is here, you know? Sure enough. Now, I could go through the whole process of actually fixing this bug here, which I tried to do as a demo, but it takes more than the few minutes I have. Okay. Any questions about that? All right. One of the things, well, actually, I'll come back to that. All right. So at this point, I will go back to my slides. And talk about the architecture and API. So my kind of goals I had, my guiding principles for this were to create something compatible, both currently with the current Java and something that would stay compatible. Some people know this is not the first time that people have tried to do a REPL for Java. And the problem with them have always been they never quite matched, and they really quickly got out of date as Java continued to evolve. We didn't want that. So this code is built on the platform directly to prevent that. We didn't want to keep chasing corner cases. We'll let the compiler team chase the corner cases and the VM team. Additionally, we want it to be really easy and natural to use. And so that's a place, we certainly tried to do that, and that's a place where I would love input from people saying, that's a little awkward or wordy or whatever it is that isn't natural. This is the time to give us that input. And to me, actually, the API, which allows this functionality to go in other tools for kind of scripting kind of functionality, for my personal use, I'd rather use a GUI-based REPL. We thought that was just way hanging over the edge of the slippery slope. So this is a command line REPL, which is what probably the most people asked for. They want simple. And we want it in other development tools. So the API is central. What's the architecture? So the big orange block there is the JShell implementation. And that's built right on top of the Java-C compiler, the standard compiler in the Java platform. And what it uses is the compiler APIs. There's APIs defined, public APIs defined for the Java compiler to allow you to do compilation. And that's how the compilation works in this. In addition, there's the execution. Well, execution is done in a remote process. The reason is if you do something to crash, you basically don't want to crash your tool. That's one reason. The other reason is because you're replacing what's effectively replacing classes. We want to make use of the redefined classes mechanism that's part of the debug architecture. So the remote process is controlled kind of by a direct socket, but also by the JDI interface, which is part of the Java debug architecture. And so the compiler, the language syntax stuff is using the standard compiler, so that stays consistent. The execution side is running on top of a standard JVM. So the execution semantics stays consistent. Now, that's the JShell implementation. The JShell implementation provides the JShell API. The tool I've been showing you is basically just a tool sitting on top of that API. It doesn't have any special permissions for anything. And for all the command line editing stuff, we used off-the-shelf functionality that we've heard good things about and was worked really well for us, which is JLine. Any questions about the architecture? Okay. What about yes?
Do you have another implementation of your client, or it's only the common client?
The question is there another implementation of the client, or is it only?
I mean, do you have something like a swing client, which is already can be used, or?
The question is there a swing client? So basically there's no restriction because what you've got here is the standard Java compiler. Anything that you compile with a Java compiler, you can compile with this module, the whole package thing, and you can use your existing classes that use any part of Java. Anything you can execute on this. So Roy just did a demo earlier today using Swing. So you don't need a special client for that.
My question was related to another question which I have, whether I can integrate the JShell in some existing application and try to introspect that
Right, okay. So the question is, he wants to be able to incorporate JShell and introspect on that particular application. That's not part of what it would provide. There's a lot of interest in basically wanting to be able to hook up with, say, long-running processes or something. The ability for this to talk to some other process is potentially there, and that's not going to be part of what goes into JDK 9. So that might get you what you want, but that's not currently what it supports. Okay, the API, which is how you would either create your own REPL how you want it, or add this functionality for scripting, or add this functionality for some innovative idea that I haven't thought of, which is my favorite ones, is you use the API. This is, the super simplified version of what the API is. You start with an instance of the JShell object, which has a bunch of stuff on it, but the most interesting thing on it is eval. So eval basically takes a string, which is a snippet input, and what you get back is a snippet event. Out at the bottom there, and a snippet event basically tells you what's happened in terms of a snippet. So it will have whatever snippet or snippets were created, whatever snippets were changed by what you did. Remember, so we had the declaration of vol. When we added cube, that changed vol because it's now a valid snippet. So snippet events are not just for the current ones you've created or modified, they're also for what changes have happened to dependent snippets. If this is something that would execute, like an expression, the snippet event will have the value, or if it failed, it will have the exception. There's also another snippet returned by a snippet event. So in the case I mentioned of adding the cube declaration, that changed the volume declaration. So for the change to volume, it will say the cause snippet is the cube snippet. So it will tell you the dependency information. Okay, but anyway, you wind up with snippets in this case. You type in a new snippet string, you'll get back a snippet event, which will hold a snippet object. A snippet object is an immutable object defining the source and basically what kind of thing it is. And from that, you can query for all that static information. Some of the information about a snippet changes, like is it currently valid? Like, for example, the vol snippet changed over time. So for that, you need instance about the state of JShell itself and about the snippet. So you can ask the JShell instance about a snippet to say what's its status, just for example. Any questions on the API? Okay. Well, cool thing is JShell went into JDK 9 2-3 weeks ago. So if you download JDK 9, either the binaries or the source, it's all there. And you can try it out by just downloading JDK 9. The plan is, again, this is, reality might interject itself. The plan is for JDK 9 to ship in September of 2016. And I don't know what else is, okay, what else is interesting on this slide is the Cola project. So we had our own repository for a while. That's no longer interesting because it's in JDK 9 now. But what is interesting on this project page is there's a mailing list, which is a great place to interact with the team, give us feedback, or contribute. There's also a corresponding JEP for JShell, which is 222. And I talk about the team. Well, so it's me plus Jan Lahota. Also, we really believe in the Open JDK, and we have Shinya Yoshida, who's contributed to the project, and we would love to have you as a contributor as well. We've had a number of advisors inside and outside of Oracle who've helped us out both in terms of reviews or cheerleading or advice. And now I'm at questions. Any more questions? Yes.
Does JShell create its own JVM process, or can it connect to the existing one?
Right. So the question is, does JShell create its own JVM process, or can it connect to an existing one? And that's what I was talking about before. So in JDK 9, it creates its own process. I think there's a lot of value potentially connecting to an existing process, but we're not trying to hit that for JDK 9. Yes?
Is it dependent on JDK 9 or will it be backported to JDK 8?
Question is, will this be backported to JDK 8? And I'm not aware of any plans to do that. It would probably not be a really big deal, but actually it would be a fairly small deal, but I am not aware of plans. So, yes.
Is the history searchable?
The question is, the history searchable? And it is not, of course. So the history is something specific to the tool. That's not part of the API.
I meant in the tool.
Within the tool, there's not a...
Or in bash.
Right. So I understand. So you would like to be able to search through the history. That's not something... Well, this is the first time we've heard that request. And so, no, it doesn't do that. I'll have to think about that so I can get more... That's the kind of feedback that would be interesting. Tell me about why and how that might be useful, and send it to the column mailing list, and we'd love to get that kind of feedback. Yes?
Can you show how temp completion for parameters works?
Oh, yeah, I was going to do that in the demo. So question was, it doesn't do completion of parameters per se, but, oh, that was, okay, and I have more. I have seven minutes. Let me actually show you. Let's get back into JShell. And, well, I showed you the API. Why don't we explore that API within JShell itself, kind of go meta on it. jdk.jshell is where the API is. So I said you create an instance of a JShell. Let's call that instance sh for shell. And there's a static method that's used to create it. And hitting tab shows that it's called create. So we now have sh is an instance of JShell. And we can use it to do an eval. Let's eval something. How about int x equals 5? So we now get back a list of snippet events. There's actually only one snippet event in there, the one for that variable. So we can snippet event. And we'll put it in an event called EVT. Well, what we got back was a list, not a, and it's the wrong temporary variable too. So it just didn't know about that. But okay, what it would have done there was it would tell me it's a list. So let's just cheat and get the first element of list. Now I have a snippet event there. And I can look, well, I can see what things I can do on a snippet event. I can ask for its cause snippet, its value, what the snippet is, an exception, the status, previous status, all kinds of cool things. So let's say we want the value. The value of that is 5. Because we've set x to 5. We can look at what the status is. It's a valid snippet, so forth. I could do more there, but that's probably... I was going to show you completion of parameters. Not sure if there's anything... we can also go back to our old the history lasts, is preserved from the last. Remember, we re-entered JShell. Well, we still have the history of this.
For how long is it preserved?
It is indefinitely. Still looking for interesting things to do. I don't know what split a stream actually. And then I can go Shift Tab. In this case, it's not very interesting. There's only one completion, which is that it wants to take a character sequence. If there were more it would list them. All right. Got time for a couple more questions. Yes.
Is there any possibility to run processes in background or to have any kind of multi-threading in?
Okay, so I get a lot of questions like, can you do this in JShell? Well, basically, if you can do it in Java, you can do it in JShell. You can run any code. The stuff you type at the JShell command line is in one package and the main thread, but you can have as many threads, you can access any libraries you want. There's no restriction on what you can do in JShell. That answer your question? Yes.
I see that you type in the complete variable name letter. Can you also have that completion?
Is there completion on variable names? Yes, there is, and there's a bug that there's a fix for and it's not in that makes it slow and lousy in demos. But it's fixed. It just hasn't... I have to quit talking and go do reviews, and then it'll work. Okay, I'll show you one more thing in 2 minutes, which I think is pretty cool in terms of showing that it's not going to go out of date, which is, some people may have heard of Valhalla, the new type system work that may go into maybe JDK 10. Well, that's built on top of JDK 9, and I can use a Valhalla image and access functionality in that, like Java anyutil, which is a new package, stream. It's probably just a temporary hack package, actually, Oh, and okay, now we can, probably more interesting thing I can show here. What could I send to range? Say a range of 1 to 100. I get back a stream of int, but notice that's lowercase int. I have more to this demo, but I have 30 seconds. So feel free to find me afterwards, and thank you.